Assalamualaikum warahmatullahi wabarakatuh. Today I would like to uh, discuss two examples so that we can understand more about the two elements that we have discussed in the previous video, which is shell element and this element. All right. Let's take a look on this first example. If you refer to the book, example 17.1. Determine the moment of inertia of the cylinder about z-axis. The density of material rho is constant. When talk about a z-axis, if you refer to this question, it says that about z-axis means that you have to find the mass moment of inertia for this rigid body when for the rotational motion about z-axis. If you are asked to find the mass moment of inertia about x-axis, for the example x-axis, so it may be like this. You have to find the value will be different for sure. All right. For this case, okay, let's start our uh, discussion. So we know that the basic equation for mass moment of inertia is I, the integration of r squared, the radius, with respect to m, or if you change this one to v, you will get rho square dv, and this one v. And then we know that v is what? V is the volume. Okay, for the shell element, what's the volume? Or instead of volume, we put dv, the changes of the volume. Okay, now I will explain to you. Let's say you have this rigid body basically can be formed if you have a multiple layers of shell element. For example, you have a small one like this. All right, a small one. You have another one a bit bigger. Try to imagine that this one is smaller than this one, and then you put it inside. So what happens is, if you have multiple shell elements, so you can form a rigid body like this at the end. Correct? So take a look on this one shell element. One shell element. We make a post-mortem for the example. All right. Try to cut this one. Cut through this thickness, and then you open up this shell element. You lay it down like this, so you can say that it looks like a plate. All right, it's like a plate, and then this length is equal to the parameter for this curve. All right, so this one is what the parameter. The equation of a parameter is 2. Sorry. 2 pi sorry 2 pi r, the radius, and then this one is h, right? H, 2 h divided by 2 times 2, you got h, and then you got the thickness. Thickness is what? Is dr, right? Dr. Okay, so this one is dr. That's why the value for this shell element is given as 2 pi r times h dr. Alright, so you can replace the equation here by this one. So you will have the I. So basically we write it Iz, referring to the axis of rotation. So rho is there. So that you integrate with respect to r. Now we change to r. So we change to rv, dv change to dr. Okay, you will have r2 is remain there, r2. So 2 pi r h dr. Now you take out all the constant value outside. 2 rho, what else? H, sorry, pi h. And then the only thing that you have to integrate is r. R2 times r, you got r cubed here. And if you integrate this one, you will have 2 rho pi h r4 divided by 4. So basically you solve this one, right? But you can simplify this mass moment of inertia by if you see that m, what is m? M is mass. Okay, so mass is, you can say that m is equal to, you integrate 1 with respect to m, correct? So you got m, correct? So dm, what is dm? Dm here, you see, dm is dm, what is dm? Dm is what? Rho dv. So rho times dv, instead rho times this one. Okay, so rho dv 2 pi r h dr. So you will have, you integrate this one with respect, not m anymore. You change to r. Alright, r rho 2 pi r h dr. So you will get that answer, which is 2 rho pi h. So you integrate r. Okay, so you got r divided by 2. If you notice that this value, this term is a part of this value. Correct? It's a part of this value. Sorry. You got 2, you got rho, you got the same pi, you got the same h, you got the same r, r2, but this is r4, but you got the 2, and this one you got 2 times 2. So you can basically, you can simplify Iz, where Iz is equal to 1 over 2 m r square. That's the answer for the mass moment of inertia for this cylinder, basically. Alright, so we have finished discuss on finding the mass moment of inertia for this rigid body using shell element. Alright, so the next example is we have to solve the problem of this rigid body but using this element. Okay, basically this element, this, if you see this or this one that I drew it, and then this one, we can say that this element is like a thin bodies, a thin cylinder, we can say that this looks like a thin cylinder. So for cylinder you have Iz half m r square, correct? So you cannot simply use this equation. You cannot use simply use the equation of this element, which is its volume is pi y square dz. Since that by time you integrate this one, r is changing. You cannot use simplify use this one. What you can say that the m, the mass the mass for this shell element, sorry, so for the disk equal to rho dv, and then dv, dv of course, dv can take it here, so dv is rho pi y square d, sorry, this is one dy, sorry, this dy. Alright, we know that I for this shell element, sorry, for this element is equal to similar to thin cylinder that we have discussed before. This is cylinder, but we say that our element, this element like a thin cylinder, where I, we can say that I is equal to half m um, sorry, x squared, because x is r here. This is x. Okay, so if I differentiate this one, di, the changes of I, the changes of I is the changes of equal to the changes of m. Alright, x squared. Alright, and then we know that dm we can replace by this system, which is equal to 1 divided by 2 rho pi y uh, pi y, sorry, this is not y basically, sorry. I make a mistake there, sorry. You can this one x, sorry, this one x, I make a mistake, x square dy, and don't forget this x square again. So you can say that di is equal to half rho pi x for dy. But this term still in term of the changes d. D means the changes of this one. But what you can do is you have to integrate both sides. You integrate both sides. So that I write it again here. Dix is equal to half rho pi x for dy. You integrate both sides. This one respect to I. This one is respect to y. So here looks like you have 1 here. You got here Iz. So here you have rho pi divided by 2. And then now you have term x4. If you integrate x4, x4 is you have to integrate with respect to y, so that you have to basically change x to y. In this problem, we see that x is equal to y squared. So x, what means that x4 is equal to y to the power of 8. Alright, you have to integrate this one, y to the power of 8 with respect to y. Then once you solve this one, you will have rho pi 2. And then you have to integrate with respect to y. So the value of y is basically for this problem is from 0 to 1 meter. Okay, so you integrate this one, sorry, 0 to 1 meter e to the power of this. So the answer is rho pi 2 y to the power of 9 divided by 9 from 0 to, and then you replace all those value. You got the rho there, 5 megagram um, per meter cube. So 5 uh, megagram per meter cube per 1000, 5000. Yeah, because you need the value in kilogram per meter cube times 5 divided by 2, and then you put the value of y. Put the value of y. I mean, y should be 1 to the power of 9 divided by 9. So, and y is 0, that this another term is 0. So you get the answers. It should be 0 point, sorry, not 0 point, 8.873 kilogram per square. Okay, that's the mass moment of inertia for these answers. Alright, I hope that we have finished discussing two example. So anything, any problems, you can let me know through WhatsApps. I know you got my numbers, and then even though you can have a discussion, online discussion through Google Meet or whatever. So anything, just let me know. Thank you very much for this session, for giving attention to this video. See you again on the next subtopic, which is we have to discuss parallel axis theorem. Thank you very much.